Hi, everyone.
Hi.
Welcome back to our channel, and we're going to start off with a number talk. Today for our number talk, we're doing how many ways to make. And if you can see the computer screen, you will see that there is the number 33. That's a two-digit number. The reason why it's two digits is because it has two digits in the number. So it has a tens and it has a ones. That makes it two digits. So right now, what we're going to do is I'm going to ask you to just think of how we can visually represent 33. And remember, that can look so many different ways. So try to think outside the box. I'm going to give you a few seconds to think about how you can visualize it, and you can write it down too to show us. And remember, friends at home, you can pause the video to give yourself more think time or more working time. And teachers are going to just put their thumbs up when they're ready to share their representation. I see Miss T's ready. We'll wait for the rest of our teachers a couple more seconds.
Wow.
Miss Hernandez is ready.
Wow.
No rush, Miss Rosales. Take your time. All right, Miss T, since you were the first one ready, why don't you share your visual representation, and I will annotate it here on our paper.
I was quicker because Ms. Rosales was so kind to get me whiteboard and markers today. So I'm using a whiteboard and markers. So I did 3 tens and 3 ones.
Ooh, all right. Let me draw that here. So 3 tens. How did you count it? I'm curious.
So I did 10, 20, 30, and then I did 31, 32, 33.
1, 32, 33. Beautiful. And do we have another volunteer to show how we can visually represent? Miss Hernandez, can you show us how you visually represented 33?
Sure.
Ooh.
So the way I counted, when I hear the number 33, I hear a 30 and a 3. So I know that 10 and 10 is 20 and 10 more is 30 plus 1 is 31, 32, and 33.
Wow, awesome. And that reminds me of counting collections. When we visually represent our counting collections, and it seems like that would be a strategy that we can use to count by tens. So we would have like a group of 10, 20, 30, 31, 32, 33. So these are two beautiful ways to represent 33. We have the tens and the ones with the 10 rods, and then the 3 ones blocks. And then we have another way to represent 33 with our groups of 10. So 10, 20, 30, and then groups of ones, 31, 32, 33. Beautiful. So next, for the next thing I'm going to ask is I want you to write a number sentence, a subtraction number sentence that makes 33. So remember, subtraction is when we take away. So that means we're going to start with a bigger number, take away another number to make 33. So teachers, when you're ready, just give me a thumbs up. And friends at home, you can pause the video to give yourself more think time or more working time. And Ms. Rosales, I'm gonna ask you to share first, since you have yet to have a chance to show your beautiful math work.
One moment. Okay.
All right, let's see.
Done, but
Ooh, okay, so we used a number line.
yes, but I realized that I didn't indicate what my hops were.
Okay, thank you for revising your work. So can you tell us, what did you do first?
So first I looked at my 33 and I thought to myself, well, if I wanted to end in 33 as my response, my number, my minuend needs to be larger. So if we're looking at a math sentence here, 73 minus my hops, 10, 20, 30, 40, is going to give me back 33. So my minuend had to be larger than my subtrahend, than my difference here. So I ended up starting with a friendly number, because we had Miss T talk about friendly numbers before. So I did multiples of 10, which is something that I'm used to. And so I started with 73, and I bunny hopped backwards on the number line, or skip counted backwards on the number line until I hit 33.
Okay, and so you started at 73 and then you counted back by tens. So you had 10 here, minus 10, and it got you to 63.
Yes.
And then another minus 10, and it got you to 53. And then you jumped again, 10 jumps, and it got you to 43, and then 10 more jumps. And then it got you to 33, which was what we're trying to make, 33, our lucky number here. So I noticed that you wrote a number sentence, and it's 73. That's what number we started with, right? 73 minus, and how many jumps it took you. So 10, 20, 30, 40. 40 equals 33. So looking at this, remember that we can create a fact family, and fact families are when the same numbers are used in different number sentences. So from this, we can make another subtraction sentence. Does anyone know what subtraction sentence we can make from this? From the same number sentence that Ms. Rosales gave us. Ms. T, can you give us the number sentence that you're thinking about?
Yeah, so I wrote the number sentence Ms. Rosales came up with at the top, and I know that in subtraction fact families, you can switch these two numbers around, because what number you start with always has to be the same in subtraction. It doesn't matter the order you take them out in, but it matters the total amount. So that's why I keep the total the same, and then I switch these two numbers.
Beautiful. And we can check our work to see if this is actually a true sentence. So let's check our work. What strategy could we use? So Miss T wrote another number sentence. She wrote 73 as our minuend. Correct, Ms. Rosales?
Yes.
Remember, the minuend is the biggest value, so the biggest number in this case. So 73 is our minuend, and then we're going to have our subtrahend of 33 equals, and it should equal 40, but we're going to make sure to see if this is correct. So Ms. T, do you have a strategy that we can use to check if this number sentence is correct?
We can do our tens and ones strategy.
Beautiful. So that is always a great efficient strategy to use. So our tens and our ones. And then what would we do first, Ms. T?
We would represent 73. So I would have 7 tens.
So we're representing our minuend because it's our largest number and it's our first number. So 7 tens, 10, 20, 30, 40, 50, 60, 70.
And then 3 ones.
71, 72, 73.
And then I would take away 33. So I'd start with the ones place first, and 33 has 3 ones. So I'd take away 3 ones, and then 3 tens. Then I should be left with 4 tens, which is 40.
Beautiful. And then we want to make sure that we put all of our work here. So on the bottom, how many ones do we have? 0 ones. And then how many tens? 1, 2, 3, 4. 4 tens, and that equals 40. So our number sentence is correct. So it is a true number sentence. So that's one other number sentence we can create, but I think we can also create 2 addition sentences, because a fact family has 2 subtraction sentences and 2 addition sentences. So what is an addition sentence that we can create with 73, 33, and 40? Ms. Hernandez.
We can do 33 plus 40 equals 73.
Equals 73. And remember, we always want to make sure that we are checking our work. So what's a strategy we can use to check our work here, Ms. Hernandez?
I'm thinking of counting on by tens.
Ooh, okay.
So from 33, I know that 40 has 4 tens, so 33, 43, 53, 63, and 73.
Ooh, so how should I represent that, in a number line or just counting?
I would break down the 40 into tens. So 33 plus 4 more tens.
Ooh, 33 plus 4 more tens. Okay, so 10. Oh, I see. Actually, it'd probably be better if I just draw this whole thing. I mean, write it. So 33 plus 10 plus, so 10, 20, 30, and 40. And let's see. So 33 plus 10, it gives us 43. And then 43 plus another 10 gives us 53. And then 53 plus another 10 gives us 63. And then 63 plus another 10 gives us 73. So does the number sentence 33 plus 40 equal 73?
Yes.
Yes, so that is a true number sentence. So we still have one more addition sentence we can create with 33, 40, and 73. Does anyone have an idea of what it can be? Ms. Rosales?
So you can say 40 plus 33 equals 73.
So 40 plus 33 equals 73. And remember, we're mathematicians. We always want to check our work. So what strategy, Ms. Rosales, can we use to make sure that this is a true number sentence?
Well, there's so many different ways, right? I would just decompose it.
Okay.
Or actually, the number, can we do the number line? I'm so used to the number line.
Uh-huh.
Can we just do a quick one, sketch it out, and do multiples of 10? So 3 10 jumps, and then 3 single jumps.
Okay, let's see. So what number would we start with, Ms. Rosales?
40.
40, beautiful. It's our first number. We always want to start with the first number we have in our number sentence. So 40, and then what would I do?
Jump 3 hops of 10.
10.
10, 20, 30, and then 3 single hops. 1, 2, 3. And then now we can do the answers below. So 40 and 10 more is 50. 50 and 10 more is 60.
Sorry.
No, you're good. 60 and 10 more is 70. And those are single hops. So 70 and 1 more, 71. 71 and 1 more, 72. And 72 and 1 more, 73.
Beautiful. So thank you for remembering that those were single hops. So this is 10 right here. We did 10 hops, 10 more because we decomposed that 33 into 30 and 3, just like Miss Hernandez did up here with our visual representation. And then we have the 1 single hops. And I want to remind us that we decompose that because we always want to try to make a friendly number so that it's not as difficult or as scary when we see that 33. Because I know I get scared when I see big numbers, but remember, you can always decompose a number. So was 40 plus 33, did it equal 73? Yes.
Yes,
so
it did.
That number sentence was true as well. So I'm going to write here in a very clear way how we can see the fact families. So a fact family is all of the digits or all of the values are used to create an answer or each other's answer. So first we started with 73 minus 40 equals 33, and we found that that was correct. Then we wrote a different number sentence using subtraction, and it was 73, the same minuend because that's the larger number, just like Ms. T had reminded us. So 73 minus 33 equaled 40, and that was correct. And then we found 2 addition sentences as well. We had 33 plus 40 gave us 73, and then 40 plus 33 gave us 73 as well. So we can see, and we can use fact families to really help us solve other number sentences or other equations or problems that we're having. And I know that this is a strategy that Ms. T has used in the past, so maybe we can use it in the future. Yes, Ms. Rosales.
Boys and girls, I just want to point out that here the 33 has different jobs, but it's still the same value. And that's the most important piece that you need to understand. 33 is still composed of 10s and 1s, and it's playing a different role with every sentence that exists in that family.
So I want to highlight that 33 just so that we can go back and we can see it. So let me show you where it is. So right here in 70 minus 40 equals 33, it's the difference, not the sum, because sum is when we're adding. So in subtraction, we call it the difference. And then here it's the subtrahend. In 73 minus 33 equals 40. And then here it's the add-in. And then it's the add-in as well here in 40 plus 33.
And then I also noticed that the pattern in subtraction is, the rule for a fact family is you have to be careful which numbers you switch. So in addition, it's always our add-ins that we can switch, but in subtraction, it's our difference and the subtrahend. So being careful with which ones we switch when we make the fact family.
We always want to make sure that the answer is true, because if it's not true, then it would be a false number sentence. So that's why we went back and we made sure that each of the number sentences were correct and we got the same answer that we said we would. So great job today, friends, and thank you so much, teachers, for helping support us. I want to see if there are other ways you can make 33. You can post it on our Seesaw and show us and teach us a little bit more. We can do this all day, but remember we have a limited time, but you can show us what you find and how you make 33. So we'll see you in a bit. Bye.
Bye.
Don't forget to subscribe.